Okay, so before I get started, just a little introduction, right? And I'm just displaying some of the challenges that we developers face when we're building modern applications, right? These are all very familiar to all of you, right? These are real challenges coming from all industries, right? So manufacturing organizations, for example, they're working to optimize factory automation, connect equipment and work sites worldwide, and doing their best to turn their big data generated by
Tonio, it's Ron again. Could you maybe go to slideshow mode so we can see it even more easily?
Yes, absolutely. But can you hear me well, right?
Yep. And I'm looking at the chat. Everyone also seems to think of the same.
Is that better, maybe?
Yep, much better.
Yep. Excellent. So we have manufacturers, right, with their needs. We have retailers that are trying to meet customer expectations of localization, personalization, by delivering these relevant real-time product recommendations and content. They're also creating these very complex global mobile services, right, that enhance in-store and online experience. And finally, we have the finance sector, where there are huge needs to build low latency applications capable to process high volume transactions across the globe, right, while ensuring that these financial services stay up and running around the clock with high availability and disaster recovery. Okay, so those are the challenges. And to help developers overcome those challenges, Microsoft created Azure Cosmos DB, which is our global distributed, highly elastic, highly available, low latency, all-purpose, NoSQL database. So I said a lot of things there. Hopefully by the end of the day, you will believe me. But let's really drill down a little bit, right? What is a global distributed?
Antonio, I'm sorry, it's Ron. It's still breaking up a little bit. Let me ask you a quick question. I know we've got the video turned off. Are you using the computer for sound?
Yes, I am.
Maybe, could you just do this? Maybe just switch to one of the call-in numbers, if that might, just to see if that could avoid some of the issues?
I'll do that right away.
All right. So I'm back in line here. We'll wait for Tonio. Tonio, as soon as I was looking to the speaker, which is to the right of me. Tonio, as soon as you're ready, just chime in and let's see if that might be a better way of using the plain old, people used to know the term POTS for plain old telephone system or plain old telephone lines. I don't think that's no longer the case since everyone's got fiber almost to their house. I'll tell you, with regard to phones, I don't know if people have been to New York City, and actually no one's been to New York City recently, but if you came back here last year, you noticed that there was an old TWA hotel by JFK that my family and I stayed at before we flew to Florida for a Christmas vacation. Again, one of the interesting things was they recreated the 1960s TWA terminal with all the same 1960 feel. So it had rotary phones, and it was hilarious because my kids had no idea how to call me in the room. When they saw the phone, they didn't know how to dial things. Antonio, how are you doing now?
I am joining the session right now.
Okay, I can hear you. I'm going to put my
Ron, can you hear me?
Yes, I can hear you, Tonio. And also looks like the attendees can as well. Now I lost you, Tonio. I see your screen, but
Ron, can you hear me?
Now I can. There you come back.
Okay. Okay. So it looks like it's weird. I have a weird echo here, but I'll just continue. If you guys can hear me, that's perfect. So I was saying globally distributed, highly elastic. Okay, so we can dynamically adapt to both throughput and storage growth or shrinkage to meet customer demand. Low latency, that means that we can achieve extremely low request latency, right, under 10 milliseconds. And this is promised, is backed by a 99 percentile SLA, which put Cosmos DB in really an industry-leading position there. And finally, all purpose. That means that Cosmos DB supports multiple client APIs, such as Cassandra, MongoDB, Gremlin, Table, Spark, and SQL. So you can store key value, tabular, graph, and document data. And by the way, this data is automatically partitioned and indexed with no schema or secondary indexes required. And finally, we support a host of first-party SDKs for popular languages like Java, Node, Python, and .NET, of course. But instead of me just talking about this, let me show it to you. So I'll just jump to the portal now. Okay, so this is the Azure Portal. This is where we create, manage our Azure resources. And what I have here is a couple of virtual machines. One is deploying the EaseUS. I'll just open it here. Okay, that's an EaseUS virtual machine. And the other one is deployed in France. Okay, France Central. So this is trying to simulate a scenario where we have a global organization. It's a manufacturing organization that has manufacturing plants in US and France. And they're all backed by Cosmos DB, which is this resource here. Okay, so I mentioned Cosmos DB makes replication, scaling, and application updates super easy, right? Let me show you replication first. So to do that, you go to replicate data globally. And what you see is all the regions in this world map. You see the regions where my Cosmos DB application is being replicated. Okay, so right now I have a copy on East US, France Central, and West US. And this provides good latency for applications that are running on the France data center or on the West Coast or the East Coast in the US. Okay, and if, for example, tomorrow we acquire a manufacturing plant in Brazil, the only thing that we'll need to do is just click Brazil here, and as you can see, it gets added. Okay. By the way, you probably notice I have multi-region rights. So this is supports writing and coordination of those rights, all managed by the service. Okay. Now, one thing I'll mention is when you have an application that's globally distributed, you have to deal with consistency levels, right? We provide you 5 different, very well-defined consistency levels that you can set at the account level. And you can also relax this consistency at the transaction level. Okay? So that's how easy it is to replicate your data globally, right? By the way, everything I'm doing here can be done through the CLI or the SDK. Now that you've seen how easy it is to replicate data, let me show you how easy it is to scale, right? To scale throughput for your application. So for that, I'll go to the Data Explorer. And here I see the 2 databases that I have created. And I also see some notebooks, right? Something I'll mention is we have this notebook interface out of the box where you can use Python or .NET to show how to manipulate the data that's stored by your Cosmos DB database, right? So If you ever want to create your own graphs or analyze the data, these samples are cheap out of the box. Let me close this. Okay, so I'll show you. Have a database here. It has one container called data, and I can see some of the items in my container. Okay. This is an example of one of those items. And if I wanted to run a query to see how many records are there, I'll just click here. And as you've probably noticed that from this interface, I can also create store procedures, which are ANSI compliant. I can create user-defined functions and triggers. So this database has over 11 million records. So relatively big database. Okay. So let's show how to scale this. And right now, this container is using 10,000 RUs. And RUs is just a way for us to measure throughput, right? The larger the value, the more throughput your container will have. So let's scale, it's 10,000, let's scale this down to 1,000. That's how we'll start our demo. And I'm gonna go to one of my VMs. This is the one that's on the East Coast. And I have this application. And there is a lot of code here, but what's important about this app is that it's simulating a brand new application that is collecting data from IoT devices, right? And we've deployed this application in one of our pilot plants here in the US. Okay, and if you look at the code, we are spawning several tasks in parallel, and we have a closed loop where we are pounding our database with lots of documents that we're trying to write at the same time. Okay, so if I run this, you can see the number of writes per second that we're achieving, right? Around 75, 80, and the number of RUs per second. Remember that I moved that back to 1,000 RUs in the portal, okay? So let's say now the business is very happy with our application, right? They love it. And now they want to deploy this on every other manufacturing plant. We have 9 more manufacturing plants. So we need to scale our system tenfold, right? Not 10%, but 10 times. So for me, from a Cosmos DB perspective, it's as easy as adding a 0 here and then saving. I don't need to worry about the data being replicated or partitioned. I don't have to worry about charts or nodes. All of that is managed by the system. And if I go back to my application, no changes, right? And I just run it again. You will see that now we're moving from 75 documents per second or writes per second to 800 and something more writes per second, right? And you see now that the number of RUs is way higher than before. So that's how easy it is to scale the throughput of an application, right? Absolutely no application changes. It's just a setting in the portal. And you've seen how easy it is to make those changes. They happen online. There is no loss on availability, okay? Of course, as I mentioned before, these changes can also be done programmatically. So you don't have to worry about someone actually logging into the portal to do this. Okay, so remember, all this rebalancing, scaling up and down is online. There is no loss on availability here. Okay, so that's you've seen how easy it is to replicate data, how easy it is to scale the data up and down, modifying throughput without really touching your database. And now let's talk about latency, right? So let me, for that, I'll go back to my East US application. And I have a different app here. This app is simpler, right? In this case, instead of simulating a write-heavy workload where we have lots of IoT devices writing data, that was the previous example. Now we're simulating maybe a machine learning process that does anomaly detection that we want to run frequently on this IoT data to identify anomalies and react quickly. Okay, so very simple application, just simulating, has a stopwatch there and sends queries to the database. And I'm right now on VM that's on the East Coast, running against my Cosmos DB database. And as you can see, the latency is around 10 milliseconds, right? Which is very good for an application that's reading data that's been generated as fast as the data generated by IoT devices. And it's very good on the scenario where you want to respond quickly to these events. Okay, I'm gonna close this up. This is the East Coast business, right? Now let's go to France. This is a VM that's been deployed on the France Central data center. Have exactly the same application there, and I'm gonna run it here. Right, as you can see, instead of having 10 milliseconds response time, we have 300 plus milliseconds response time, which, for this scenario is not good enough, right? There is too much latency there on those reads. Now, this is happening because our application that's in France is querying the data across the ocean to the East Coast database, right? But we don't have to do that because we have, as you remember, a database that's been geo-replicated and is sitting on the West Coast, on the East Coast, and is also sitting in France. So from a developer perspective, the only thing that I need to do is when I deploy my application, configure the locations that I want to use, right? So I purposely comment out this location here, which is the primary location. I'm gonna save and rebuild the code. And I'm gonna run it again. And as you can see, the latency goes dramatically down. It's exactly the same application. And right now it's talking to the replica that exists in France. Now, from a developer perspective, I have to do nothing, right? If I want to increase the latency, the only thing I need to request is to have a Cosmos DB replica that's closer to where my application lives, okay? So that's how we will manage latency. Let me go back to the slides here. Okay, so hopefully by now you have a pretty good understanding on how you can manage replication of your database in a very easy way, how you can increase and decrease throughput of your application without any changes in code, and how you can address any latency requirements, right? By using the replication feature in Cosmos DB. So this replication gives you not only high availability and disaster recovery capabilities, but also gives you an opportunity to have this low latency on your applications, okay? So let's see, we'll go to the next slide now. Now, one key feature I will mention before I move to this slide is that all these changes I've been making, they are all with no loss on availability, right? They happen instantaneously. Now, let's see. One more thing I'll show you before jumping to the slides. Let me go to the portal here. I talk about replication, how easy it is, throughput, and now on latency, how to reduce latency, right? So we've deployed this IoT application into our factories globally, and now the business comes to us, they tell us, well, we have a new requirement, right? We've upgraded the firmware on these IoT devices, and now they're gonna start sending new data points, right? And we want our application to leverage those data points. Now, you were working with a traditional database, that means a schema change, potentially an index change, on a charted, globally replicated database. Right? it is a complex process that you have to coordinate and plan for. Let me show you how you will do it on the Cosmos. Right, I'll use this IoT database as some sample telemetry. Here is a sample of the document, right, that the IoT devices are sending. And let's say right now the IoT devices have been upgraded and now they're sending some tagging information, right? The only thing that I need to do is really update the document. And let's say they are sending where in the manufacturing line they are located. They are sending a manufacturing line code. Okay, so just add that data point. We'll update this document. I just updated the schema of this document, right? And now, because it's Cosmos DB, I can query for that. Right? Use some of the native functions in Cosmos DB. And there you go, right? Schema change, index update. From the developer perspective, you have to do absolutely nothing, right? The database is ready to receive the new payload out of the box. So your new IoT devices can just send you that new information, and the database will take that information, and your application will be able to start querying and using that immediately. So as I mentioned initially, very easy to replicate, very easy to manage throughput, very easy to deal with latency, right? Applications require low latency. And from a developer perspective, extremely wonderful, right? How to manage schema changes, for example. Let me jump back to the slides here. With all these features that I showed you, these are some of the scenarios that are now available, right? You can build these real-time customer experiences. It's ideal for gaming, IoT applications that show you e-commerce, right? If you are building e-commerce website that has a recommendation engine, it's very common to have a propensity score per customer that you can store in a database. Now, from a website perspective, if I'm opening a website, my next best product, I don't want to wait a second for that to be shown on my page, right? Otherwise, I'll just move out. So having 10 millisecond latency on retrieving that information is great from an application perspective. Right? Another thing that I didn't mention is that you could run Spark Analytics on top of this data. Right? We have a very nice feature called Analytical Store that exposes the Cosmos DB data to a Spark cluster that you can run inside Azure Synapse, which is our new offering. If you haven't heard about Azure Synapse, I strongly recommend you to look it up. These are some of the top use cases, okay, for Cosmos. And I won't read all of this slide, but just walking through them, right? Real-time telemetry is exactly what I just showed you, right? A very write-heavy workload that need to ingest large volumes of data, unlimited throughput that you can scale by, as you see, just adding another zero and saving it, and provide low latency on queries, without having to worry about indexing or schemas. The second scenario or use case is a real-time recommendation, exactly what I was talking about, right? If you're building a website that needs to provide recommendations, it has to be on the millisecond latency. This is a web app. If you have your user waiting for more than 2 seconds, they just fly to a different site. When you have the need for mission critical or geo-distributed applications, right? In the example I gave you, it's a manufacturing company that has manufacturing plants in France and US. Using Cosmos DB is a natural selection for that, right? The replication is as easy as clicking on a map. By the way, I didn't talk about automatic failover, right? But if one region goes down, there is a disaster and one region goes down, the application doesn't need to make any changes. It automatically and very gracefully fails over and connects to the next available region. And we provide you this 5 nines of high availability that's financially backed. So if for some reason we fail, we'll pay you back for that. And NoSQL migrations, right? Maybe you are already very familiar with NoSQL. You love the benefits of using NoSQL for your applications, but you don't want to manage it, right? You want to maybe focus on high business value operations, right? So we can run it for you, we can manage the service for you, and you will focus on building apps that provide true business value. Those are some of the top use cases. Now, things that you need to know when you start your journey. This applies to most NoSQL databases, especially to Cosmos DB. The first one is partitioning, right? Partitioning is the way that we achieve scale, right? The way we scale out our database. So when you start your journey, you need to make sure you select a right partition, okay? This is normal in any distributed environment. This could be Spark, this could be an MPP database. It's the same with NoSQL databases. So make sure you select the right partition that avoids having bottlenecks, right? Or hot partitions, right? A partition that receives too much of the data or a partition that receives too many of the requests, right? Pick a partition that evenly distributes those two. And don't be afraid to have a very, very granular partition. If you have a unique ID on your data, that's an okay partition to use, right? The next concept you need to know is request units. That's what I call RUs. Right? You saw me changing that from 1,000 to 10,000 and magically increasing the throughput of our applications. That is a discrete unit we use for performance and cost. So you pay per RUs, right? And you saw how you can dynamically increase and decrease those values. You can do it through the portal or through programmatic APIs. And there is a feature called autopilot, where you basically don't have to worry about RUs anymore. We will automatically increase and decrease that based on your workload. So depending on really the type of application you build, you can select to manage that by yourself or to let autopilot do it for you. Things that I didn't mention, time to live, right? So there may be a requirement for some of the documents in your application or your entire collection to have documents that expire 3 weeks after they've been inserted or a month after they've been inserted. So you just set the TTL for the entire container and the documents will be automatically deleted following your policy. You can override the policy at the document level if you need to, but these are basically free deletes, right? You have that need to purge documents. It's great not to have to worry about it, right? You set it at the container level and we take care of that for you. And finally, the change feed feature, right? This is a message queue-like semantics on the Cosmos database. So every transaction that happens, every change that happens on the Cosmos database is pushed to a queue, a Kafka-like queue that you can programmatically read and do something with the data, right? In my case, maybe I want to read the change feed and sample it and run it through a machine learning model to do anomaly detection, right? Or maybe I want to do some data to noise filtering, to filter the data that's coming from the IoT sensors, right? Or maybe I can use this change filter to create aggregates on the fly, right? And push that telemetry to maybe a Power BI dashboard. Many things that you can do with this change feed that's just an out-of-the-box feature for Cosmos DB. Now, additional resources. There are two pretty good Pluralsight courses. I strongly recommend you to take a look at them. And you can also use our free Microsoft Learn resources. If you go to that URL, you will find a learning path with many modules. I'm actually in the process of updating some of those modules. So if you have any feedback on how to improve our learning content, more than happy to hear from you. And once you're done with your learning, right, going through the documentation, going through these classes, and you are ready to deploy, go to that site, that URL. You will find plenty of labs on GitHub that you can deploy play around, look how Cosmos DB gets used in different scenarios, an IoT, retail scenario. And it will give you pretty good ideas on how to use it on your application. And with that, I want to thank you. Thank you for taking the time to attend this session and open to questions.